Okay, so how do mole ratios work? Remember that we're going to look at coefficients, and we know that coefficients are the numbers in front. And notice here, there's no number. If there's no number, what is the coefficient? 1. Good job, Deja. If there's no coefficient, it means 1. Clear? Very important. Okay. Now, we're going to say, just like if I make cookies, that I have 2 eggs for every 1 cup of peanut butter, that could be a ratio, just like that. I'm going to do a ratio using the coefficients to the chemical equation. And the chemical equation, I'm going to give it to you already balanced, so you don't have to panic about that step. I will give it to you already balanced, and then you're going to use the coefficients that are already there. Okay? So, when we do these, we're going to answer the question in the order that the question is written. NH3, okay? Go to NH3 in the equation. What coefficient do you see?
2.
2. Okay, so there's 2 moles of NH3 for every, okay, notice, then it says 2 N2, and 2 nitrogen, in other words. Okay, go to nitrogen. What's the coefficient on nitrogen? 1. Even though it's blank, we know it means 1. So 1 mole nitrogen. I'll read it again. For every 2 moles of ammonia, NH3, there are 1 mole of nitrogen. Some people would probably have you just answer 2 to 1. Both answers are the same, as long as the question is showing. Okay, let's try another one. Notice here it's the opposite. On this one it says nitrogen to ammonia. Ammonia is the NH3. So look at nitrogen. Since it's first, we're going to do it first. What's the coefficient for nitrogen? 1. Okay, so 1 mole of nitrogen for every, okay, how many moles of NH3? 2. 3 moles of NH3. Okay, so notice this one. Oops, I put 3
Isn't
in
that
it.
supposed? Oh, but
You caught me. Yes, I realized I wrote that wrong. 2 moles of NH3. Okay, so notice this one is 1 to 2. It's exactly the opposite because the question was in the opposite order. Just keep it in order of the question. Is that okay? We need to do a couple more, don't we?
Oh.
Okay, let's do this one down here. It says hydrogen 2 NH3. See it? Okay, go to hydrogen. How many moles of hydrogen are in the equation? 3. The coefficient on hydrogen is 3. So I'm writing 3 moles hydrogen, dot, dot, okay, the colon. All right, it says 2 NH3. So go to NH3, what's the number? 2. The coefficient on it is 2. So 2 moles NH3. And if I simplify, if it only asks me for the ratio, and it gives me ratio choices, I could say 3 to 2, because the answer, the question will be there, and 3 to 2 will make sense because the question is there. 3 moles of hydrogen for every 2 moles of ammonia, or NH3. That's how I prefer to read it. I prefer the labels, but I have seen questions that only have you put 3 to 2 as your final choice. Are you okay with that? And sometimes we have to reduce it. Like if there was a question at some point that said 4 to 2, or actually there's one right here. Here it says, for this equation, aluminum oxide to aluminum, okay? Aluminum oxide is a 2. Aluminum is a 4. 2 and 4. We can reduce that, can't we? 2 and 4. We can divide by 2, can't we? So notice it shows it reduced 1 to 2. Because if you divide both of them by 2, okay, 2 divided by 2 is 1, and the 4 divided by 2 is 2, there it is reduced. Sometimes we reduce it. Doesn't happen very often, but it can happen. You okay with that? All right. Now let's do the slightly tougher ones. But again, this is nothing more than like using a recipe or box of mac and cheese. If you double it, instead of 2 eggs, I'll use 4 eggs, just like that. This is exactly the same thing, only it's with a chemical equation, and they're telling us specific numbers to use. Now I'm going to copy the equation so it's bigger to see. We have gallium iodide breaking down into gallium and iodine. The equation's already been balanced like this. Okay, I just wrote the equation bigger so you can see it better on camera. Now, the question, all right, what if they gave us 4 moles of gallium iodide? So this is going to become 4 moles of gallium iodide. Now think, how did they get from 2 to 4? What did they do? They doubled it, right, they multiplied by 2. That's all we're going to do. If this one has been multiplied by 2, you are right. This one's been multiplied by 2. That means everything has to be multiplied by 2. So, how many gallium do you really end up getting? Not 2, but 2 times 2, which is 4. 4 moles of gallium. And how much iodine do you really end up getting? 6. Because 3 times 2 is 6 moles of iodine. So if I fill in our notes page, I'm going to put 4 here because it had to double. Oops, it had to double in order to make 4. That 4 is already there, pardon me. And it had to double it, so 2 times 2 is 4 here. And we had to multiply by 2. 3 times 2 is 6. And that's how we got those numbers, okay? We multiplied by 2 to make them all happen. All right, let me fold this one out of the way. Okay. There. The old one's out of the way now. Okay, now we're going to say we have 6 gallium, okay? The given on the next statement is 6 gallium. Now, how did they get from 2 moles of gallium to 6 moles of gallium? What did they have to do? Multiply by 3. Okay, they had to multiply by 3 to get from 2 to 6. They had to have multiplied by 3. So once again, if this is multiplied by 3, then everything has to be multiplied by 3. We must keep the ratio the same. Law of conservation of mass says whatever mass you begin with, you must end with. So if you end up with more, you had to have started with more. So triple it. How much gallium iodide do we end up really starting with? 2 times 3 is 6. So in order to get 6 moles of gallium, we had to start with 6 moles of gallium iodide. Had to have started that way. Okay? And if we make 6 moles of gallium, how much iodine do we really actually have to end with? 3 times 3 is 9, because we have to triple it. Remember you said they tripled it, they multiplied by 3? Again, everything is tripled. We have to triple everything because this was tripled. This was like the guilty party that got everything started. Because that was multiplied by 3, everything had to be multiplied by 3. And that's why we end up coming up with 9 on the iodine. 3 times 3 is 9. Good? All right, so again, I'm going to fill in these answers. I'm going to correct where I accidentally wrote one wrong. So this is really 6. We just did it. And this is already the given, and this will become 9. Let's look at the bottom one. This was all tripled to make it happen. The bottom one has us ending with 15 moles of iodine. So hide my old question. Here we're going to end with 15 moles of iodine instead. Okay, now how do you get from 3 to 15? What do you have to multiply by? Exactly. Do you feel like these are a lot easier now? Maybe. And it's okay to use a calculator if you just can't think straight about it for a moment. I don't know if this will make sense, but if I see 15 given to me, and I can see their coefficient is 3, I can do 15 divided by 3 and say, oh, they multiplied by 5, because the answer would be 5. And then I know what happened to it. And then I know what to do to everybody else. If this was multiplied by 5, then everything must be multiplied by 5 for me to know how much I started with or ended with for the other things.
So that's gonna be 10?
Yes, gallium iodide will be 10, you're right. 10 moles of gallium iodide had to be there for us to be able to get 15 moles of iodine.
Okay,
Yeah, and how much gallium had to be there to get 15 moles of iodine?
10 also.
10 also, because 2 and 2, didn't that make it easy?
Mhm.
Yeah, and so you understand it right there, that's all. So again, I'll copy this to my notes. 10, it already gave me 15. We had to multiply by 5, which means we had to multiply by 5 to get all of them correct. And that's how we get it. Are you okay with it? Okay, so I want to make sure I'm not going too fast. I don't want to confuse anybody. This is the first part of the assignment, how to manipulate mole ratios.